In question 1, what we're asking you to do is actually calculate the return on investment, the current yield, and the capital gain yield for each period. Let's bring back this to a normal view. So in question 1, what we're asking you to do is calculate the current yield and the capital gain yield in order to total them up and see what the total yield is. So if we look here, the data set that we have closing values. So values at each of these dates. You'll notice that each one is a month different, the month apart from the previous one. So we have monthly values here. We're going to be able to calculate with that the increase in value, so capital gain. Here on this side we have the actual dividend that's being paid out in that particular month. So our current yield, dividend yield. So let's start with that one. So if you look at my equation here, the only thing I'm doing, I'm dividing my current dividend by the value at the beginning of the period. And we're going to do that over and over because I'm asking you here the monthly returns. So the investment is now worth $22.74 and you're making 12 cents of capital gain, 0.53%, so on and so on. Because I was asking you to calculate a monthly return. Here we're going to look at the capital gain. I'm doing it this way, B5 divided by B4. In other words, $22.07 divided by 21.48 minus 1. I know some of you think it's confusing, this minus 1. You could do 2207 minus 2148. The result of that increase divided by 2148. You will get exactly to the same result. Right? Once we've done that, and we've done that for each period, and again, each period here, we're always going to be looking at 2 different months. So the first month and then the following month, all the time because we're calculating monthly returns. Here, the total yield. That was the answer to question 1. So once you've done the first line, you could copy this down all the way to the last period up here. When I want to rank them in question 2, you could just decide to have a look at them. I'm using here the rank. You could have also decided to select all this and put them in order of the smallest to the largest total yield. I'm just using the rank function here. I just wanted to test out the rank function. Rank says figure out what the rank is for a certain cell, this one, in a range. Make sure you're putting the dollar signs inside of the range so you can copy this down and you're always selecting the same range to be looking into. Well, notice number 1 is the highest value, 6.46, while on the other end of the spectrum we'll find the highest ranking, 122 minus 1.47. We might have something bigger here, 25 minus 7%. I also use the min and the max functions here to also show which one was the highest and the lowest. That was more of an Excel question anyway. Question 2, part 2 at least. I'm asking you here to figure out what is the annual return. So we're going to redo exactly the same way of thinking, but we're going to be using different dates. Here we're going to look at the whole dividend for the year. So a sum of the dividends from February all the way to December, all that divided by my initial value, 2148. For the second year, we're going to be doing the same thing from January to December this time, because we do have here a dividend in January, whereas the previous year we did not have one in January. And we're going to divide that by the beginning of the value at the beginning of the period, 2168. So that'll be slightly different here. Again, result for the total year. Capital gain yield for the total year. Let's have a look at what we're doing here. January 2012 divided by January 2011. I'm not looking at the added value in every month because sometimes it's going up, sometimes it's going down. I want to see from year end to year beginning. That is what I'm calculating. Here, 0.93. In the following year, we're going to start at our ending position, January 2012, going to January 13, and we're going to have 3.60. Now I could add these together. Again, remember, when we're talking about return on investment like this, it looks a lot like the simple interest equations. Here, last question I was asking you for the total investment period. So the value you've actually invested, the money you've actually invested is $21.48. Over this whole 2-year period, you made 13% of current yield, which is probably somewhat very, very similar to what we have here. We have 12.69 because there are a few months missing there. Calculation is a little different. We can't really add them together. It looks a lot the same, but with slight variances. Our capital gain yield, we started at 21.48 and we finished at 23, so we made a 7% yield. Now if we look at the total yield, the capital gain yield we had here, completely different. Completely different. We made a little yield in the first and then we made a little bit at the end, and it totaled them up, we never get up to 7%. Anyway, so this is just to show you it's impossible to really just make and sort that everything works, that we can go from an annual to 2-year yields, and our grand total over the 2 years was 2104. So there are elements here in return on investment that are not always mathematically perfect, but it's a good tool. Again, same type of thing. We're looking at, we have a different set of data in here, and we were looking for the capital gain. Now here we don't have prices for each and every period. We have a price to start with, a price at the end, and this is what we want to know. Since we've purchased this in 2010, what has been our yield? So I'm looking at all the income that I've received. $1.25 in each period divided by $96. 15%. The capital gain yield, let's go look at the equation. I'm looking at this, 96, and now it's worth 99. So I've made a capital gain of 3%. The difference between the two divided by my initial investment. And I'll calculate my total here. I think the only part that was a bit complicated was here. I was not giving you the interest amount, but you had everything here to calculate the interest amount by calculating the rate here that we had 5% per year, and you could divide this by 4 to get to the 1.25 per quarter, and then just figure out how many quarters you needed between January and this January 2010 to January 13. In this last part, we were looking to calculate the yield to maturity. The yield to maturity means not the period that I'm holding. It's if I bought this at 96.58, I'm getting $1.25 of interest. There's 16 payments, so I didn't have 16 payments here, but there are 16 payments up to the maturity until this bond comes to term at the end of its lifetime. So that was found in the problem here. What is the value of this bond when it comes to term? Well, you've bought it at a discount for $96.58. It's going to be worth $100. So let's figure this out. Number of periods, we have 16 periods. Payment, $1.25. Our present value, $96.58. That's the value we have today. At the end of these 16 periods, we're going to get $100. What is the rate that this generates? 1.49. What we have to remember here is that these are quarters. Our payments are quarterly, so my rate here is quarterly. I can multiply it by 4 to come up to my nominal rate per year, and then find the effective using my nominal rate per year, 4 periods of compounding, to figure out that my effective rate is 6.1. Here we're looking at a payback. A payback period means an investment. We have $12,000 to invest, and we're going to be getting a return, a payment of $1,500. That's going to be constant. The question is, how many of these payments, so how much time, how many periods do I need of this fixed payment to repay my $12,000? Here notice there's no interest, there is no notion of interest in a standard payback. So since this is the same amount all the time, we could go through the long equation, just make the subtraction. So 12,000 is left my balance at year zero. After the first income of $1,500, I've repaid that off my capital of 12,000. I'm left with 10,500, so on and so on, until I've completely repaid my $12,000 investment. 8 years. Since this is a fixed amount, we could have just strictly decided to go with a division, 12,000 divided by 1,500, and that would give you 8 years. So it takes 8 years of this $1,500 payment to repay my initial investment. Here, a little complicated. We need to figure out what is the future return. So we need to figure out what is our price today, what are our future earnings, and what is the future value. So our price, previous price, $18.87. Our current price is $20. We're saying that the evolution, the growth, will always be the same. It'll be the same on the price, and it will be the same thing on the dividends. So what I need to do here is calculate my growth, because that is not given. I need to calculate that. Again, same equation here. You could decide just to do 20 minus 1887 divided by 1887. It will give you the same result. I like entering them like this. 20 divided by 1887 minus 1. We could go through the arithmetic here and show you that it is exactly the same equation, and it's giving me 6%. So there is a 6% growth between these two amounts. Once I know that, I can apply my 6% growth to my capital, to my value, and I could apply the same 6% to my dividend. Once I know what the future dividend is and what the future value is, then I can actually just go back and see what is the capital growth, the capital gain yield. You'll be surprised to see a 6% because this is what we've been using. And we'll also look here, what is our new dividend, $2.11 divided by my current price. Current dividend is 10% plus this total yield, $16.59. So in question number 5, we have here, we know what their price is. We know we're investing $30. $30 is our investment, and we want to figure out what is the interest rate, what is the return we're going to be making, knowing that today's dividend is $2 and the dividend will be growing at 5% per year. So what I'm looking for, today's dividend, 2%. I'm looking for tomorrow's dividend. Tomorrow's dividend will have grown by 5%. That also is given. So if today's value is $30, what we're looking for is the dividend in the future. Knowing that this dividend will grow in time, we have this equation up here. So this goes back to our perpetuity with a growing factor, a growing perpetuity. P0 would be the price today for that's equal to the dividend divided by the interest rate less the growth rate. So ing here would be in parentheses to make sure that if you want to understand that ing are the dividers. So 30 is equal to dividend tomorrow, 2 multiplied by 1 plus 5%. This is 2 increased by 5%. This is our first part up here. We're dividing that by I minus 5%. So I put my parenthesis here so it's really clear that this is my divider. What I have to do is now solve for I. This is what I'm doing in the following steps down here. So since I'm dividing here by I minus 5%, I'm going to turn that I minus 5% over here as a multiplier and also transfer my $30 into the parenthesis to get rid of that. So that makes 30 times I minus 30 times 5%. And that is equal to 2 times 1 plus 5%. So in this case, I did two different parts of the equation all in one here when I transferred the I minus 5 to the other side of my equation by a multiplication, and then I distributed my 30 inside of the parenthesis. Which brings me to the last part down here. Since we've isolated I on one side, then I could take my 30 times 5% and place that onto the right-hand side of my equation up here as a positive with a positive sign, and then divide the whole equation here by 30 in order to get rid of my 30 on this side. That will be I. So I will be equal to 2 multiplied by 1 plus 5% plus 30 times 5%, and all of that divided by 30. Result, 12%. So that is the interest rate that I will get. It is the return I'm earning from this investment. In question 6, again, another investment here, 18,000, but the investment will not generate an income, it's generating a saving. Well, what we need to see here is that even if it's not an actual factual income, if you're saving money, it's net income to you. So we're going to treat this savings, these savings of 33, 28, 23, 23,000, 21,000, and 18,000 as new income that are relevant to the $18,000 investment. In other words, if you don't make this 18,000 investment, you will not generate this new saving, not making any income. So let's go through the payback up here. Here we don't have a fixed payment. We have a mixed stream. So no other way than to go through the equation here and go through the whole subtraction. So if I look at my equation here, all I'm doing is subtracting the 33,000. All I'm doing here is subtracting the 33,000 from my initial investment and looking at the balance. Following year, doing the same thing over and over. Just looking at my balance, subtracting the new amount. And you'll see that after 6 years, I still have a $34,000 balance. In other words, my savings have not repaid my investment. There's still $34,000 in the balance. In other words, my saving do not amortize the investment over 6 years. We should not authorize the investment. In B, what we're looking at is slightly different. We're going to look at the same $18,000 of investment. We're going to look at this as a, again, mixed stream, and just let's calculate here the internal rate of return. Am I making a return out of this? You'll notice my internal rate of return is negative. In other words, this generates minus 6%. Doesn't generate 0, it generates minus 6%. So I'm losing 6% every year. Again, another great indicator to say IRR is negative. We should not do this investment. So for question number 7, what we're looking for is a payback period. If you look at the way I've displayed this, it's just organized a little differently. I've been setting up my payback periods vertically in the previous problems. Here I just set it out horizontally. It looks more like the layout we're using for IRR calculations, but it's set up to calculate a payback balance. If you look here, we have a $25,000 outlay, and we have income for $7,000 per period up here. What's being calculated on the bottom is just the balance between the $25,000 and the accumulated $7,000 every year. So this is an annuity. So I'm just going to subtract. We'll notice here 3 years we have at $4,000 balance. So our payback period is 3 and something. So I just make the division here and I get 3.57. So I just typed in my 3 because it was 3 years, and then the division between 4,000 and 7,000. So 3.57 years. B, I'm asking you to do the same calculation but using the discounted payback period. So here what I'm using, I have the same cash flow, $25,000, the $7,000 payments, and what I've done here is just the present value. I've just made a present value of the $7,000 at 15% discount rate, which was given in the problem, in 1 period. Then doing that over and over, using again the $7,000 as your future value, 2 the number of periods, and 15 the interest rate. So these are my present values. I'm going to subtract these present values from my 25,000 up to this point. This point I have a fraction again that's going to be expressed here that's under 0, that's under 1. So this tells me the payback period is 5 and something. The division between the two gives me 0.507. So total payback period discounted 5.507. A lot bigger than the payback period we had in a non-discounted. Here I just determined the number of periods using another method. Okay, since we have here 15% is our interest rate, we have $7,000 which is an annuity, we have 25,000 which was the P0. I just decided to use my NPER function. So number of periods, calculating using the discount rate, the payment, and P0. This tells me exactly how many periods are required to amortize the whole 25,000. And if you look here, very precisely 5.49 compared to this 5.50, pretty precise. So we can imagine that 5.49, so about 5.5 years, is the right payback period discounted.